recorded, and so please take note of that. We are so delighted to have so many classes of students joining us in addition to other folks. And so let me go ahead then, and without further ado, come over here to my PowerPoint. And today we are focusing, like I say, on connection and collaboration. We're going to be hearing directly from some of Mrs. Audra Edwards' high school students from Hawkins, Texas, as well as from both Globe students and scientists in Nigeria. This entire year, we have been focusing on learning about the different ways that Globe scientists, teachers, and students around the world are studying their water. So we'll continue now going and taking a kind of a more focused, putting the spotlight on specific Globe schools and teachers and students and scientists, and finding out from them about water in their environment. We'll be beginning with Audra Edwards students, like I say, in Hawkins, Texas, and there we can see them and see what their school looks like. And then after we hear from them, we'll hear from our wonderful Femi. And there Femi is when he was visiting one time. He's in front of the White House, and I took that picture. I had the pleasure of that.
Hey, Dorian.
Yes.
I don't think we can see, you can't see your screen.
Well, thank you very much. That's good to know. Let's come back here and see why it's doing that. Okay.
Real technology.
Is that working now?
No.
Nope. Okay. Yeah, it's funny. Like I can see it on all of my screens, but how about now?
Nope.
Nope. Okay. Let me come back. Let me come to share screen. It says host disabled screen sharing. Well, I don't know why it won't share my screen, but I will, let me see if there's a way of stopping it. It's telling me host disabled attendee screen sharing. It will not let me do anything. So Brian, I'm going to leave the meeting and come back. But in the meantime, Audra, once I leave, then you'll be able to jump on, and then Audra, if you go ahead and start sharing.
Okay. So did you unmute it? Okay. Hi, can everybody see me? Wave at me if you can see me. Okay, great. Hi, my name is Audra Edwards, and I am a teacher here at Hawkins, Texas. And these are a couple of my students, and they just want to tell you a little bit about our research that we've been recently doing. So where's Femi's group? Am I seeing Femi there? Can you wave at me if you're with Femi's group? Yes? Okay. All right. I see you down there. All right. Awesome. All right. So the boys are going to go ahead and start with their presentation.
Going ahead.
All right. So my name is Dalton Wages. I'm 17 years old, and I'm currently a junior at Hawkins High School.
And I'm Tristan Dotson, and I'm also a junior at Hawkins High School, and I'm 18 years old. And we have a little presentation for y'all, just to kind of start it off and talk about our community and what it's like living here in East Texas. Uh-oh. Well.
Okay. Brian, are you there?
Yep, I'm here.
Okay. I'm not sure. It says we're not able to share screen. It says host disabled.
That's funny. That's the same thing I was getting. So annoying.
Yeah.
Nothing's disabled on this side. Let me, okay, let's try now. It looked like a setting was turned strange. Try it again.
Okay. I think we've got it now.
All right.
Okay. So.
Good old technology.
That's right. Makes it kind of exciting.
All right.
Looking good.
Yep, it's going good so far. Boom.
All right. So We are from East Texas, and these are a few of the scenes you can see around East Texas, and we're going to tell you a little bit about our town.
So our town is itty bitty, located. We're about an hour, north or south of Dallas? South of Dallas, in the middle of nowhere. You won't know much about our town, but you know we're not too bad. We have a population of about 1,300, and here at school we do a bunch of different things. We play all the sports: football, baseball. Might be a little different depending on where you are in the world. You can see right in the middle, that's a picture of me actually playing a golf tournament yesterday. I didn't do very good, so don't ask me about it, but that's okay. We also like to perform live theater. If you look at the far right, that's a picture of our cast from last year, and we go to competitions and perform for the public in many different settings. And also a little small fact about our town. We are the pancake capital of Texas, which doesn't really mean a lot, but we have that title, so we get to say that.
All right, and so like he said, there's around 1,300 people living within our town, and around 250 of those people are employed by Ozarka, which is a water bottling company, and around 200 are employed by Exxon. So around half of the people in Hawkins are employed by these two companies.
And a little bit about our community as far as the nature goes. We have lots of wildlife. In that top right corner, you can see a picture of a little deer. We have lots of deer out here. We have lots of pine trees. The grass is really green. Most of the time we have great weather. Recently we've been getting a lot of rain, so it's not quite as fun. We love to swim, fish, boat, anything you can think of, we've got it here. And another big sort of way that we can earn income around here and support our local community is through agriculture. As you can see, we grow a lot of watermelons during the summers, and we also raise lots of cattle. Anywhere you go out here, you can see a cow and a field, lots of cows. So anything you can think of, it's being raised out here, grown out here. We've got it all, and it's a great community, a great environment, and it's a great little East Texas town. That's kind of our intro for it, I guess, and talking about our school and whatnot. I don't know. I guess somebody else is going to take over from here. Not real sure. We don't do the whole presentation.
No, that sounds great. Thank you so much. And now that was so interesting. Love to hear the ways in which you guys are using water and also what your community looks like and the things you do at your school. And now I believe we'll hear from Dr. Akin students, or perhaps from Femi, just to tell us a little bit about the community. And I'm not sure, Femi, are you the one that's going to be telling us about your community, or will it be Dr. Akin and students?
Both of us will talk about our community, but
beautiful.
Let me just quickly share the screen with you.
Thank you. Wonderful.
Hello, everyone. Can you hear me loudly?
We hear you, Femi. You sound great, and we see your slides perfectly.
Okay. My name is Oluwafemi Olawale, but for short, my friend calls me Femi. I'm a citizen of Nigeria, and as you can see from the slide, Nigeria is actually located in the middle of the world. Nigeria, 9 countries in Africa, 14 degrees north to 3 degrees east to 15 degrees east of the equator. The landmass is around 923,769 kilometers. And it's unfortunate that I think I need to add at this junction that Nigeria is a very huge country when it comes to landmass. It's a very huge country. And the seat of power is actually in Abuja. Some years ago, the seat of power was in Lagos, but about 10 years ago, the seat of power was moved out of Lagos because of the population explosion in Lagos down to Abuja. And the country has about 36 states with 774 local government area. Like I said earlier, my name is Femi. I work as a research officer with the Nigerian Space Agency Center for Geodesy and Geodynamics. Center for Geodesy and Geodynamics is actually one of the research centers of the Nigerian Space Agency. And as one of the tasks of the member of the Science Working Group and Globe International Science Network, I'm obliged to pick a school, a Globe school, to work with and to do my educational outreach. And that was why I chose Baptist Secondary School, which happens to, okay, let me quickly talk about my home institution, which is the Center for Geodesy and Geodynamics. That's our main observatory, as you can see the Google map. We also have a Globe study site location at CGG, where we do some Globe activities with industrial attachment students that actually we normally receive industrial attachment students twice in a year. So I actually work with them. We have a Globe study site that we do most of our observation. And let me quickly talk about Globe Nigeria. Globe Nigeria is actually domiciled at the Federal Ministry of Education, in Abuja. And the Globe Nigeria actually works with partner agencies like Nigerian Space Agency, Federal Ministry of Science and Technology, Federal Ministry of Environment, Federal Ministry of, and the NEMA, National Emergency Management Agency, and with some few institutions. And this is a picture showing First Baptist Secondary School, Jos. I think I need to add at this junction that First Baptist Secondary School is a Christian-based school established to assist the indigent students within the community. So basically the school was established to provide educational resources for less privileged students within the Jos metropolis. And as you can see from the map, from the slide, this was during one of the outreach programs that we had a few months ago. And as you can see, this is when we were embarking on the surface temperature campaign in Nigeria. And this is also a picture showing the deep introductory presentation that we had about 2 years ago, because I was privileged to be selected by I was selected to be one of the GPM master teacher in 2014-2015 school calendar, and I chose Baptist Secondary School as a school that I work with. And as you can see from the slide, these are the students with their science teacher and the school administrator. And this is also a picture showing some of our Globe students that participated at the 17th Globe Annual Maryland, United States. And I think I need to quickly thank Professor Kelvin at this junction for giving me the grant to attend the 17th Globe Annual Meeting. And that was my first appearance at the Globe Annual Meeting. I think I need to thank National Science Foundation that gave me the grant through University of Geography of Nigeria. Nigeria enjoys the humid tropical climate characterized by hot and wet conditions. And the country is also characterized by two air masses, tropical maritime and tropical continental. These two air masses brings 3 different seasons in the south and 2 in the north. And The two seasons are the long rainy season, the short dry season, and the short rainy season. All these three seasons occurred, or we experienced them at the southwestern part of Nigeria. Then in the north, we have the long dry season and the short rainy season. Then my location, which is Jos, is in central Nigeria, is a location, is a city that is located on the plateau, high plateau. And Jos is one of the cities that has the high altitude in Nigeria. We have, Jos is located on the high plateau of about 1,250 meters above the sea level. And that gives rise to marked different dry and wet season when you compare to Adamawa State, like Gombe State. Plateau State has a unique, fascinating climate that makes it different from other cities or states within the northern part of the country. Then this is a slide showing the mean annual rainfall from 1941 to 1980 within the whole country. I think Dr. Akinwumiju will be presenting more on this. We discovered that the rain decreases from the south to the north. And the relative high rainfall on, there is a relatively high rainfall on Jos, located on the high plateau, and that gives rise to very low temperature when you compare to other cities within the north. Jos has witnessed series of communal and religious crises that has affected certain infrastructures. When you talk about the city of Jos has experienced, now the city is a little bit calm. And let me quickly talk about water crisis in Nigeria. Nigeria is abundantly blessed with water resources. And I think I need to add at this junction that virtually all the 36 states in Nigeria are named against a river. And that tells us that Nigeria is potentially rich in water resources. But unfortunately, 19% of the population has access to safe drinking water. Jos is not left out of this crisis. And as you can see from the slide, there is a daily report. There is a newspaper report that came on 3rd of March 2013, talking about the water crisis in Jos. And these pictures, I took this to drinkable water. Then I'm saying Globe Nigeria have Globe Students of the Globe programs. One of them is the GPM Student Feed Campaign. In 2014, 2015, I was privileged to be selected as the GPM Master Teacher, and I was working directly with some of these kids at First Baptist Secondary School in Jos, whereby we collected rainfall observation. We are also involved in soil surface temperature analysis. And I think I need to add at this junction that there is also a program coming up in Nigeria, and that is what we called Globe Nigeria Malaria Habitat Mapping Project. The Globe Nigeria Malaria Habitat Mapping Project is a project that we want to bring up in conjunction with the U.S. Embassy in Nigeria. We've been in contact with them. We met quite some months ago, and they have given us their word that they will surely support us on this project. We have discovered that malaria has been a very serious problem in Nigeria. And looking at the water quality can also tells us the amount of mosquito larvae that are available in some of these waterlogged areas. So in this project, we'll be looking at the water quality, because studies have shown that acidity of the water can also instigate the prevalence of mosquito larvae. So we're also building collaboration with relevant organizations like Association of Nigerian Geographers and with some of the universities in Nigeria, and like the University of where Dr. Akin works, the Federal University of Technology. We are trying to build a collaboration with them and see how they can be part and parcel of the GLOBE program. We also have an intention of joining the surface temperature feed campaign that will come up between 1st of March to 30th of March 2018. And I think I need to thank Professor Kevin at this time around for donating infrared thermometer that we normally use in our soil surface campaign. I think I need to switch over to Dr. Akin. And thank you for giving me the. It's so unfortunate that it's extremely late in Nigeria, and some of my kids are unable to join this webinar. It's extremely late, and Dr. Akin will pick from where I stopped. Thank you for giving me an opportunity.
We appreciate you presenting for them, Femi, and thank you for telling us about the area, the part of Nigeria that you're joining us from, as well as giving us an idea about the availability of clean drinking water. While we are waiting for Dr. Akin to load his presentation, if you will put in the chat box.
Where's my Ondago?
Oh, very good. We see you. Hello.
Hello, ma.
Greetings.
Yes, thank you, ma. Where is the account? All right.
And
well, yeah, minimize it. Where should it be?
Down at the bottom there.
Yeah. Okay. Yeah. Oh, okay. Slideshow.
Like,
okay.
Slideshow.
Thank you, Femi, very, very much.
Thank you too.
It's here. Just look on. Yeah, this is it.
Yeah. Okay. Yeah. But I don't know.
Okay. Now share screen.
Okay. Yeah. Okay. Then I will. Okay. All right.
Looking good.
Where is that?
All right. Brian's updating us on all the different places that around the world who are joining us.
Hello, ma. Can you hear me?
One.
Hello, ma.
Dr. Akin, we can hear you loud and clear. You can go ahead.
All right. My name is Akinwumiju Akinolashola. A citizen of Nigeria, born in Ondo Kingdom, southwestern Nigeria. So we are speaking directly right from Akure in southwestern Nigeria. He has talked a lot on he has discussed a lot on the climate of Nigeria. But in southwestern Nigeria, we have double. We usually experience a double maximum rainfall, and right now we are at the onset of rainfall in southwestern Nigeria, which will peak by the mid of July. Then the rain will subside and pick up by August and peak again at the middle of October. And by November, the rainfall will be reducing drastically. And by December, we believe that we are already in the dry season. But right now in Akure, we have there are challenges right now as regards to climate change and its impact on this part of the world. Currently, we are experiencing what is known as urban heat island as a result of a change in the climate, because the average temperature, both the minimum and the minimum and the maximum temperature, is rising on yearly basis. So as a result of this, Nigeria is, the southwestern Nigeria, especially within the city centers, the climate is not, is becoming uncomfortable, particularly at the peak of the dry season. So I'm going to let my students go through the presentation. But once again, I am Akinwumiju Akiola Shola. I am a lecturer in the Department of Remote Sensing and Geoscience Information System, Federal University of Technology, Akure. I am also a globe scientist, and I have over 40 students listed in the globe program, right in the Federal University of Technology here. And we have the mission of taking the globe program to secondary schools, so that all the students, we have secondary, at least a student will have secondary school to himself, where we have group of secondary school students that will be taking on through the globe protocol. So I'm going to hand over to the students. They are going to take you through the slide. Thank you very much. So you scroll for him. That's him. Do that.
Okay, my name is Joy Oluwafemi Olawale, a student of the Federal University of Technology, Akure. I'm 20 years old. And then we are going to be giving you a general overview. I'm going to be speaking on Nigeria as a whole. Prior to what Mr. Femi has said, Nigeria as a country is inhabited by a lot of students, a lot of people. Nigeria is a multi-ethnic country where we have a major ethnicity of 7 ethnic groups. And the northern part of Nigeria is dominated by the Hausa Fulani, and the southern part is for the Yoruba and Igbo. Okay. Nigeria is densely populated. Even in the world, Nigeria is the 7th most populated country. But in West Africa, Nigeria is the 1st most populated country. But as a country, Nigeria's population decreases from the south down to the north. Lagos as a state is the most populated country, the most populated states in Nigeria. And then based on our climatic region, we have 4 climatic zones in Nigeria. The wettest part is in the southern part of Nigeria, and the warm part is in the northern part. The northern part is even becoming desertified due to warm temperature and the fact that their own site has a very warm, dry climate. Based on availability of water, we have most of the water we use in Nigeria is from boreholes and well. And then based on our climate, the rainfall of Nigeria decreases from the south to the north. And then, according to what Dr. Akin said, we are experiencing what is called urban heat presently, and everywhere is becoming so uncomfortable, especially during the day in the urbanized part of Nigeria. The weather is always very hot during the day, and then that's about temperature, like I just said. And then based on rainfall, like Dr. Akin, we are going to like Dr. Akin just analyzed, and we have 9 months of rainfall and 3 months of dry season. Thank you very much. I will hand over to my next speaker.
Hello, my name is Ojo Abisola. Our study area is the Federal University of Technology, Akure, which is located in the southwestern part of Nigeria. So, the Federal Technology of Akure was established in the year 1981, and the vision of the university is to be a world-class university of technology and the center of excellence in training, research, and service delivery. The mission of the university is to promote technological advancement by providing conducive environment for research, teaching, and learning, engenders development of products that are technological-oriented, self-reliant, and relevant to the society. This is the City Hall in which the school is located, Akure City Hall, and this is the nearest tourist center, which is Idori EU. And this is the area photograph of the university auditorium, and this is one of the lecture theaters. in the school. This is the university library, and this is the administrative block. This is the Waska climate station in the school, and this is the top climate station. The rooftop climate station in
I'm 23 years old. I'm a student of Department of Remote Sensing and GIS. So we are talking about FUTA as a case study. And FUTA depends on multiple boreholes for the source of potable water. And here in Akure, like Dr. Akin has explained the last time, the main source of water here is rainfall. And due to the fact that we need water for different sanitation purposes, cleaning, so the school, some of the school lecturers and students, we engage in small-scale rain harvesting. But the school has is having a standing MOU with the state government to have a proposed pipeline, pipe-borne water for the school. And also, the school, due to the fact that here in Nigeria, most of our sources is based on underground water. So after the school pump the water and store it in an underground tank, and it's being purified and chlorinated. Thereby, it is being distributed to other parts of the school community, the academic building and the residential area within the school. The underground water is being sourced by the rainfall on the green space, and the aquifer are being recharged by water from the wetland. The FUTA is mainly dependent on borehole, and they are located around the wetland. In the school, and this is the main source for the aquifer during dry season. Therefore, there's a need for sustainable management of water resources, and it can never be overemphasized. Thank you very much.
I am Ogunde Shei Manuel. For the sake of this global program, this project is going to be centered on the impact of surface temperature on the hydrological system in FUTA here. And we use infrared thermometer to take the surface temperature on different places in the school campus. We took the temperature of the bare ground, the third surface, the forest, the grassland, pavement, and wetland. And this temperature are taken at different time of the day. 7:30 a.m. represents the morning time, 12:30 p.m. the afternoon, the 5:30 p.m. the evening, and the 7:30 p.m. later in the night. So the first picture to my right hand is showing a student taking the temperature using the infrared thermometer, and that's manual method, using the infrared thermometer. And as a geoscientist, we took the coordinates of each of the location, and that's what the picture at my right hand is explaining. Next slide. Sorry. This slide is showing the pictures of different locations. Different locations like the wetland, light forest, the grassland, the pavement, and these are the pictures showing the locations. Thank you.
All right. Good evening. My name is Amoduta Emmanuel. I'm an undergraduate student of FUTA. For the past days now, we have been working on different locations, checking the surface temperature readings of this surface in order to know how this surface radiates heat. And here is a chart of our data that we got from the field. Here you can see from this horizontal axis, we have the time. We took it four times in a day. Then we have the location, we have the light forest, we have the forest, we have the grassland, the bare soil, the pavement, the wetland 1 and wetland 2. The wetland 1 is an open area, while the wetland 2 is a covered area with vegetation. And on the vertical axis, we have the temperature in degree Celsius. And if you get from the chart, you can see clearly that the pavement has the highest temperature, pavement is a black surface which absorbs and radiates heat. So that's the main reason why it has the highest temperature. Then we have the wetland also. The wetland has water which absorbs it, and it takes longer for it to radiate it. That's why the wetland has the lower temperature. Right. So, and okay, from this is talking about the slides that were presented. So paved surface has the highest surface temperature. The surface temperature is generally high by noon period across all surface. By noon, the sun is at its peak, so it's radiates to the floor, so everywhere would be hot. So surface temperature of wetland and vegetated area are observed to be than that of tarred, paved, and bare ground surfaces. Because a vegetated area has a canopy that prevents it from getting to the ground, then those developed areas are characterized by extremely high surface temperature. A developed area does not have tree, it doesn't have, majorly it's an urbanized environment. So there's no way, there's no canopy, there's nothing that can prevent the sun from getting down to the floor. So that's why a developed area are characterized by extremely high surface temperature. All right, thank you. I heard about this point.
Yeah, thank you. My name is Salahuddin Taslim. I'm a student of FUTA here in Akure, Nigeria. I'm basically a developer, and I'm going to present how we acquire our data. Now, for the past few days, we've used the manual method by using the manual method to acquire our surface temperature. But now we intend to expand our reach over more areas so that we can have more derivatives from what we acquire. So now we plan on developing a device using IoT, that's Internet of Things, that we could plant across each location or each spot of the interest. Then this device, we have the ability to acquire the surface temperature and humidity, and probably the ambient temperature also, and upload them to a web server, of which right from our lab or office, we could access this data easily. Now this will ease our way of acquiring data and expand the amount of data we get daily. And even with this, we can increase the time frame we acquire data per day to maybe 10 times in a day, and also maybe across several locations around Akure entirely. So we made a prototype and we tested it and it worked. But that is just one prototype. So we intend to create more of this device and plant across several areas. So that's how we could acquire more data and increase our database. And at the end of this, we could compare our results gotten physically, and that's how we gotten with our device, with our web maps that shows the temperature of the soil surface. Yeah, thank you very much.
Yeah, good day. My name is Audra Kay Edwards, 5-level student of the Department of Remote Sensing and GIS. So my age is around 23. Our research objective is to monitor the nexus between spatio-temporal variability of rainfall in wetland characteristics and groundwater level fluctuations in our campus, FUTA, surface and groundwater quality monitoring, and short and long-term monitoring of the variability of weather parameters across the campus, FUTA campus. So also we talk about our outreach objective. Our outreach objective is to take GLOBE program campaign to 40 secondary schools in around our city, Akure, and have GLOBE students in at least 50% of the schools, enlist more undergraduate students into the GLOBE scientific group across our campus. Thank you.
So thank you so much. That's the presentation from my students. So I hand over to you, Daria.
Dr. Akin and students, that was absolutely wonderful. What fascinating research you are doing. So thank you. Thank you so much. And now we will pass the screen on to Mrs. Edwards and her students in Hawkins, Texas. Really fascinating presentation. And I'm going to turn my video off so that I'm not taking up too much bandwidth.
All right, we're going to get back to the PowerPoint here.
You guys are great. Thank you.
Thank you.
All right, and so here in East Texas, we use water, we revolve around water basically because, I mean, we're always, during the summer, we're either fishing, we're either swimming, skiing, or out in boats. And so we enjoy time around the water a lot. And we have a lot of rainfall. Well, we have a subtle amount of rainfall here. We have 37.5 inches on average. And so in Texas, water is just about anywhere you go. You can be driving down the highway and you'll see water. And I don't think there's a time where you can go 10 minutes without seeing water here in Texas. See, water covers about 270,000 square miles of Texas, and so that's quite a bit of land. So we decided we wanted to look into it and see how clean this water actually was. And so when we were testing our water, we were using several globe protocols. We used water temperature, dissolved oxygen, conductivity, pH, salinity, alkalinity, nitrate, and turbidity.
And because here in East Texas we spend so much time around water and we're already using globe protocols to test the water, we wanted to try and take it a step further and see what else we could do with this. And so as we were scouring the internet, looking for different places to go and what more we could do with our research, we came across an old article about a steel mill about 50 miles from here and a local body of water called Lone Star Lake and how it was being affected. And we found it to be very interesting, and it turned out to be quite a big deal after we looked into it. And then the pictures you can see here, we traveled to Lone Star, Texas, where this lake is, and right beside it is this old abandoned steel mill. And it's still very much protected. It's still under government control. That's why we weren't able to get in and get better pictures. The factory itself is unoperational at this point, but the factory is still there, and you can still see some of the equipment. And the reason that this article caught our attention was because from 1940 to 1980, when this steel mill was open and operational, they were taking water from this local lake and they were using it to cool the steel. Well, the only problem was after they were done with that water, they were putting it back into the community lake. Now, since this was a community lake, people were fishing here. They were swimming here. Just about anything you could do on a recreational lake. They were even pumping this water back into their house, and they were bathing with it, and they were drinking it. And the problem was, because the steel mill was using this water to cool their steel, it was creating high amounts of mercury within this water. And whenever they would dump it back into the lake, it affected the entire lake. And its effects are still very much present today, even though the company has been unoperational since the 1980s. But from here on out, the effects have been everlasting. It's taken control of the fish population here. And recently we traveled there, and whenever we got to the lake, after these few pictures right here, we noticed that it was very barren. We didn't see a lot of fish in the main body of the lake of water. We didn't see any turtles, any ducks. There was no vegetation on the bottom of this lake. It was very barren. There weren't people out fishing or swimming, but the power plant is still right across from the lake. And so it caught our attention. We were very interested with it. And here in these pictures, this is when we were running our tests on the lake. And the far left picture is when we were at the main body. And this kind lady was nice enough to let us test in her backyard. And we started going through all of our protocols, and we were getting strange results as far the pH. What was the pH? What was it? It was very high. It's what we can remember, and it was very obvious that this lake, they didn't have high or normal levels. It was low dissolved oxygen. It wasn't looking good. And we were also testing right beside a water pump that led into this lady's house. And that sort of concerned us, the fact that people are still pumping this water into their house and still drinking it, even though this lake's, past is, ever so tragic. And back to the steel mill itself, after it was shut down, several people started getting very, very sick from this mercury poisoning. Not only the workers in the factory, but also the people who lived around the lake, and several of them died. And from the cancerous objects that it caused within the body from consuming the fish or consuming the water. And so a court case was opened up against this factory. And that's where we found a lot of this information. And the court case was opened in the 80s, and it went on for several years before finally being resolved. And when it was resolved, the settlement was over $70 million. And for the longest time, up until about 2 or 3 years ago, it was the largest court case in the U.S. itself. And it was really interesting. And then this middle picture here is when we left the main body and we went to an outlet of the lake where it had been overflowing whenever we got too much rain. And here you can see a lot more vegetation. You can see trees, you can see plants. And we also found a lot more macroinvertebrates. We found there were fish there were bugs. It was much healthier than the main body. And we believe that's much healthier down here is because whenever this water would overflow, even though it still had the high levels of mercury, all of this vegetation was able to sort of filter it out and make it much more sustainable for aquatic life.
And so, as you can see on the right picture, that is the main body of water. There's no vegetation hardly around anything. And at the bottom of this lake was just straight sand, and it wasn't good. And so, like, in the left two pictures were at the outlet of the lake, and there was much healthier findings. So we found a lot of mayflies, and there were fish, and people were fishing, and so it was seeming much healthier at the moment.
Certainly. And as far as our global collaborations go, for several years we've been communicating with students from a school in New Delhi, India, and that was East Point. And they were able to send us information about their local bodies of water, and we were information about ours. And it was a great collaboration effort. We were able to compare data. And, you know, that's what we're all about here. That's what Globe's all about, is working together to further our research. And so it worked out great. And that was set up by our past Globe members. They have since graduated. So Dalton and I have taken over, and we're back into the swing, and we're working to further this project. And the only way we can do that is through collaborations with India, with students from Croatia, and, you know, hopefully from Nigeria now, and wherever we can get it.
All right, and so these collaborations, they go all the way back to 2012 and 2014 when our previous Globe group took a trip to India, or took two trips, and so in the middle you can see our teacher, Miss Edwards, talking to Manta Agra, and in the top left you can see Miss Edwards and one of the old students communicating with the student from India, and on the right you can see our students were talking over the computer with students from Croatia.
Back to the body of water that was surrounded by so much controversy. This is near the outlets, away from the main body. As we were driving by looking for new sites to test, we came across several bridges with people fishing off of them. And whenever we stopped and asked them, you know, what they were doing, they told us they were fishing. You know, they were trying to catch food, because that's what we do here in East Texas. We fish. We love to eat fish. Well, whenever we asked them if they had any idea about the lake's past, they had no idea. There's hardly any way for people around this lake to understand and know what exactly was going on in that lake. And so that kind of sparked our curiosity, and we tried to do some digging on the internet, and it took us a little bit to find any information on the lake as far as regulations. You know, did the government put out anything to warn people? Uh-oh.
You're right.
Fix it. You know, did the government put out anything to warn people? And they did, but it was on the Texas Parks and Wildlife site, but you had to search for this information. There were no signs around the lake to notify these people that there was a consumption ban on these fish. And the consumption ban was actually 4 ounces. I believe it was 4 ounces a day, which, you know, if you've ever eaten anything, 4 ounces is not a lot. Certainly not for a little East Texas town like this where we love to eat fish. And so that shocked us, that these people had no idea, you know, what effects could be awaiting them. And yet they're still out here. And it was you know, it was just strange. And it felt strange that, you know, these people could just go on and do this, and they had no idea. And actually, right before this bridge, whenever we were pulling up, we noticed several piles of deceased fish. And they didn't look like they were just thrown out on the bank, or perhaps they were just trash fish and they were thrown away by people. It looked as if they had died from the causes of the main lake, because there was no other evidence to prove that a person killed them or there were any other effects other than what we had found at the main lake, which was there was no probable sustainment of life. And so it was interesting to see that, and that these people were just fishing right beside it and they were paying no mind to it. And ever since we've found this out, we've wanted to try and see what we could do more to raise awareness for this, to let people know that, this is very deadly and their lives could be in very much danger if they continue to do this.
And so like you said, we're going to try to take this to the next level and talk to people about it. And so we plan on talking to our state representative, Cole Hefner, and because he has an office that's about 10 minutes from where we attend school. And then U.S. Congressman Louis Gohmert has an office about 30 minutes away. And so we plan on talking to them in the near future.
Certainly. And over the summer, we were able to travel to Connecticut near Yale University in New Haven. And we were able to go to a science symposium and meet lots of great people. We met several of you there, and it was a great time. And we made lots of great friends and connections. And it was announced that the next meeting, international meeting, would be in Ireland. And we are very much looking forward to that for the simple fact that what we're doing here is a great thing. We're all coming together to better the future of science. And the only way we can do that is to work together. And that's why these meetings are in place. And we just can't wait. It's going to be a great thing, and we're really looking forward to it. And we're looking forward to seeing all of you, and hopefully we can work together in the future to keep this going and keep doing great things.
Wow, you guys were also so incredibly inspiring to listen to Dr. Akin and his students, to hear the things that Femi is doing in his part of Nigeria, and then to finish it off with learning about some of the ways in which in the United States, down in Texas, you are watching the water quality and then also trying to figure out what some next steps are. Once you have done some of these investigations, found some potential problems, it's really neat to hear you going from kind of the observation, data analysis, now to communicating your results to others, and as well as doing that in Ireland. I won't be there, but Brian will, so I look forward to hearing what he has to say and coming back and telling us about all the good work that everybody is doing. So you guys rock. Thank you so very much. You and Dr. Akin's students have just been such good communicators of the science that you're working with and the things you're doing. And you'll notice we had classes today from all over the world. Bulgaria, Poland, Argentina, lots of different parts of the United States, listening to some of the things that you have been working on and Dr. Akin's students have been working on, and also giving them ideas for things that they may consider doing using GLOBE protocols to better understand water and their environment. So thank you so much. And I think we'll finish off by hearing from Brian Campbell.
Thank you.
Thank you.
All right, so yeah, I just wanted to echo something that you guys just said. You know, we want to work together. That's a huge thing with this campaign, and of course, GLOBE as a whole. That, as you can see with this webinar, this is awesome. We brought schools from I forget what the numbers are exactly. We have schools from 1, 2, 3, 4, 5, 6, 7 different classrooms in 3 countries: Nigeria, Peru, and the United States. We have Pennsylvania, Texas, Michigan, Ohio, and Puerto Rico. So we have lots of people learning about what's going on in Texas and in Nigeria, but that only says that they want to learn, about your environment. I like to stress that, everybody can take measurements. Okay, making sense of the measurements is one thing, but then another thing is, why do my measurements matter to someone else in another part of the world? Say you're taking measurements. Say you're taking pH measurements in a pond in Texas. Okay, why should that matter to somebody a student in Nigeria? And these are the type of things that we're trying to focus on here. Is that we're all one planet. We're all connected. things happen the same in different places, things happen differently in different places, but that's how we connect. We connect with things. With this campaign, we're connecting with water. Okay, what is water like in our environment? So a very awesome job to everyone who presented today. And what I want to do quickly is do a quick shout out for our next. Some of you have been participating in these. These are our SOTA webinars that are part of the campaign. So these SOTA webinars focus on short observation data analysis. And our next one is on Thursday, March 28th at 8:00 p.m. Eastern Standard Time. And that is actually on the 29th, it would be the 29th of March at 1 a.m. UTC. So this is all about something called the Genesis Project, where they were collecting data, and the data that they took was taken by local environmental group for the state of New York to mitigate some of the things that they've noticed in some of the measurements they were taking. So we're going to have two speakers. Bob Konecki is a recently retired teacher who's been working on this project for a while, and one of his former students, Emily Pope, who's now a university student. She's a college student at Nova Southeastern University. But they're going to talk about this. And then in April, which I don't have the screen visual for because we haven't set the exact time yet, but in April, we're going to be working more closely with some of the current students in New York who are working on projects about water and the environment, the New York watershed, looking at these guiding investigative questions that are part of the ENSO campaign. So we're super excited to have this, but if you can, come check us out. It's 8 p.m. on March 28th, which is also 1 a.m. UTC, March 29th. So what we'll do here is we will ask if anybody has any questions. And I'm going to stop sharing my screen. If anybody has any questions for anybody on the webinar, feel free to unmute and we'll go from there. We have about 3 minutes or so. If we go a little over, that's fine as well.
I don't have a question. I just want to say that was awesome, man. That was good stuff today. Good job, everybody.
Based on the rank and whoever the higher ranked seed is, which would be like the lower number.
Thank you so much. And will everyone be sure that they're muted unless they are talking? Otherwise, we're hearing some conversations. Hey, Jeff, thank you so much. Appreciate that. And it really has been wonderful to see so many classes here today. This is awesome.
I think I want to make some changes now that I have that information.
Anybody have any questions for anybody on the webinar?
I don't have any questions, but I do want to say that I think everybody did a great job, and this is awesome that we're able to come together and do this. And let's do it again. Let's keep this up. This is great stuff.
For sure. I do see in the chat from Richard in Puerto Rico. He said that his girl's project on water filters used after Hurricane Maria and bacteria levels could be useful to our friends in Nigeria. So that's really, really, really important there. So, let's get Richard's classroom and, folks in Nigeria collaborating together to see what they can do.
And just a reminder, in order to collaborate really, really easily, on the Globe website, you can go down to the collaboration bar and you can find different people. For example, Richard's class should reach out to Femi and to Akin and then ask to collaborate with them. And then you can be doing that, and interacting with each other on an ongoing basis. But also let both Brian and myself know if you want to be connected with anyone, and we'll make sure that we help to expedite that process. It's our pleasure. Oh, good, Richard, perfect. So we have Richard's email in there and Femi's email. Love. This is so nice to see everyone collaborating. Also, great minds thinking alike here. I had put a little blurb in for people to remember to share your water stories. And I was taking copious notes, and I'm going to send a couple of ideas for possible water stories that I pulled out in listening to this to Mrs. Edwards students and to Dr. Akin students, because you have some really, really rich stories to tell. And I'll kind of show you how easy that is. And you already have the pictures ready to go. So way to go, folks. This is a fabulous group. Love working with everybody.
I love all the emails coming out. The collaboration has begun.
Yeah, that's awesome, awesome, awesome. And thank you, teachers, for bringing your students here today. We really, really loved seeing so many students from all over the world joining us. And thank you.
Yeah, and I think what she wanted was more specifically what the partners have done, and I didn't really track that.
Well, I think we can go ahead and stop the recording. And thank you, everyone, for sharing emails who wanted to collaborate. And thank you, Femi. Thank you, Dr. Akin and students. Thank you, Mrs. Edwards and students.